Hey guys, welcome back to Know How Right Now. Previously known as A Math Lab. I just switched the name. Alright, today we're going to go over really simple graphs. This might be good for you if you're in a pre-algebra or college level algebra and you're just trying to get a hang of these graphs. So I'm going to show you a graph and then I'm going to show you the reason why it kind of looks the way it does. And hopefully you can kind of look at these, memorize them, and then that way later on if you're trying to construct your own graph, you know it should look sort of like this, what I'm about to show you. Let's start off with a very simple one. Let's start off with y is equal to some constant. It could be any constant. Right now, let's just say something, let's say it's 5. Okay? What does the graph of that look like? Well, if I make a table, which I encourage you to do, especially when you're trying to get a hold of these graphs of x and y values, if x is 0, then what does y equal? Y equals to 5, right? In fact, if x is any number, y is going to equal to 5. So if this is the x-axis and this is the y-axis, then at any point on this x line, for any value of x, y is going to equal to 5. So 1, 2, 3, 4, 5. So basically, it's just a straight line, right? The straight line goes to infinity unless otherwise specified. But in this case, for any value of x, y is going to equal to 5. So that's a very basic one there. Now let's just say y is equal to x. Right away, when you see something like this, y is equal to x, well then all that means is that for any value that you plug in for x, y is going to equal the exact same thing. And I can tell you that the graph is going to look like this, okay? Here's your, just assume from here on out that this is the x-axis and this is the y-axis. Because if I plug in anything for x, if I plug in a -1 right here, well then y is going to equal to -1. So -1. If I plug in a 0, then y is equal to 0. Right? Because if I plug in a 0 for x, y is equal to 0. If I plug in a 1, y is going to equal to 1, 2, 2. And it keeps on going for infinity. I can plug in 2 million right here and it's going to equal the same thing for x as it does for y. And so if I graph this, so 0, 0 is right here, -1, -1 is right here, 1, 1, and so on. If we keep on going, it's going to keep on going up like that. So that's basically the reason why that graph looks the way it does. Let's go now to, that was linear first of all, by the way, because here, this is assuming that x is to the first power, okay? X is to the first power, y is to the first power. So that's linear. What if x is quadratic? What if it's squared? Well, then the graph of x squared is going to look like... The graph of x squared looks like this. It's a parabola. And you'll probably hear this quite a bit. You'll be dealing with a whole lot of parabolas. And in order to find this, all we got to see is, okay, well, if I plug in a value for x, well then what does y equal? Well, let's plug in 0. If I plug in 0, x, basically, y is equal to 0 squared, which is equal to 0, right? So, when x is 0, y is equal to 0. If I plug in a 1, well then 1 squared is 1, right? So 1, 1. It starts to get a little more interesting here when we plug in, let's say 2, for example. When y is equal to 2 squared, then we have 4. So if x is 2, y is 4. Okay? What about if we plug in a negative number? Then you got to remember the whole negative times negative rule, which is this is really saying -1 times -1, right? Which is equal to 1. So if x is negative 1, then y is 1. If x is negative 2, then y is 4. Okay, so now this let's see if this graph corresponds to my points here. At 0, 0, here's my point. At x is equal to 1, y is equal to 1, here's my point. At x is equal to 2, y is equal to 4. X is equal to 2, y is equal to 4. X is equal to negative 1, y is equal to 1, and so on. And it keeps on going like this. As my x's go to infinity, basically the slope gets steeper and steeper, and so if we looked all the way up here, you know, my graph would keep on going up, steeper and steeper, almost until it looked like it was vertical, but it would never quite be vertical. It would basically be approaching infinity. And actually, if we take a look at it, if we drew x values all the way out here to, like, let's say the other block or so, this would keep on going to the right, to the right, to the right, but it would be getting steeper and steeper. So it's a pretty interesting graph if you think about it. But let's move on here to x cubed. So we're keeping it quadratic. Let's say x cubed. So what does the graph of that look like? Let me get another marker. Alright, let's see. X cubed. What do you look like? Well, the graph of x cubed looks like this. Like a parabola, but it goes down like so. And why is that? Why does it go down like this? Well, that's because if this number is negative on the inside, then it's going to stay negative. So, for example, at 0, 0, you know, we can see y is equal to 0 cubed, which is equal to 0, right? So that stays the same. Let's say we want to throw in negative 1. Well, that's the same thing as saying negative 1 times negative 1 times negative 1. So negative 1 times negative 1 is a positive 1, times a negative 1 is equal to negative 1. So at x is equal to negative 1, y is equal to negative 1. So if x is equal to negative 2, well, that's the same thing as saying negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is equal to 4, times negative 2 is negative 8. And so, and if it's positive, then let's say, well, it's the same numbers here, but only positive. If I plug in a 1 for x, then I get 1 back. If I plug in a 2 for y, then I get 8 back. And so, if I plug these numbers in here, here's my 0, 0. At negative 1, I have at x is equal to negative 1, y is equal to negative 1. At x is equal to 1, y is equal to 1. And so on and so forth. If I plug in something right here, then it's going to be right here. If I plug in an x value right here, then it's going to be right here. And that's the reason why that graph looks the way that it does. Okay, so let's move on really quick. I don't want my video to get too long and boring. Let's say y is equal to the square root of x. That's going to look like this. Okay? Basically, the reason why is because if y is equal to the square root of x, well then if I plug in numbers here, at 0, y is equal to the square root of 0. Well, the square root of 0 is just equal to 0, right? And so that's this point right here. If I plug in a 1, the square root of 1, if I plug in a 1 for x, the square root of 1 is equal to 1. So at x is 1, y is 1. And let's skip to something that's kind of easy, like a perfect square root here. For example, let's plug in the square root of 4, which is equal to 2. So here, if x is 4, y is 2. So x, and this is where it kind of gets interesting. Okay, so x is all the way out here, and then y is just at 2. And so as you can see, you can throw in bigger values of x, and y isn't going to be quite as big because you're squaring it. And that's the reason why it looks like this. Now, the graph doesn't go this way because we can't put in an imaginary number. A negative number, because then we'd be graphing imaginary numbers, and we don't want to do that. So basically, if we plugged in a negative x, or a negative number, this is x, and this is negative 1, well then that actually equals an imaginary I, and so we don't want to do that. So that's the reason why we don't see anything on this side of the graph. We just see positive values. Okay, so there's a basic graph right there. Let's see, what's next? Let's say we have e to the x. I don't want my video to be too long. Let me see. Where are we? Oh, we're already at 10 minutes. Okay, so really quick, e to the x looks like this. And at this point right here, y is 1, so x is 0, y is 1. Because if we say y is equal to e to the, let's say x is 0, so then we plug in our 0 right there, well, e to the 0 is equal to 1. So at x is 0, y is 1. And so the graph goes through 0, 1, and up into infinity. And same here. It goes to infinity this way, and it gets closer and closer to this y-axis, this x-axis, but it never actually goes through it. And so there's an interesting graph. Make sure you memorize it, because later on if you're plugging in numbers, then you're going to want to know that your graph is going to look like this. Okay. And then also really quick, before I end this video, the natural log of x, which is where you have something like this. Basically, here at x is equal to 1, it's a little different. Y is equal to 0. So x is equal to 1, y is equal to 0. That's because if we plug in a 0 right here, the natural log of 1 is going to equal to 0. Y is equal to the natural log of 1, which is equal to 0. And that's the reason why it passes through this x-axis right here. And really quick, I know I keep on adding stuff to it. I'm going to make another video, I promise. And if you have any questions, just feel free to leave me a comment or email me or something. But really quick, if we have y is equal to x, and it's negative, let's say, then what do? We have originally it was like this, right? Well, now it's negative, so everything flips. So now it's going to be like this. And the same thing with our parabola where y is equal to negative x squared. Instead of having that parabola that goes like this, now we have a parabola that goes like that. So it's basically reflected. And we'll go more into that later on in other videos. So once again, if you have any questions at all, just let me know. I'll be more than happy to look at it and hopefully make another video for you. I hope you enjoyed it. Thank you.